Scenario. Satellite A is in a circular orbit around an unknown planet with a constant tangential speed of VB. Question. What are the variables that can affect the tangential speed of satellite A? Here's the answer. The tangential speed is defined by V is equal to the distance or the displacement divided by the time. The circular orbit, the distance around a circular orbit can be defined as the circumference of a circle, which is 2 pi r, and the time for an object to revolve around a circle is called t, which stands for the period. So the things that affect the tangential speed would be 1, the distance between the satellite and the planet, which is r, and second, the period capital T, which is the time required for one complete revolution around the circular path. Please note that pi is a constant, it is not a variable, so it does not affect the tangential speed of the satellite. The following up scenario. A comet now collides with the satellite and knocks it further away from the planet. The distance away is 4 times as before. What is the new orbiting tangential speed of the satellite? This is asking for the tangential speed of the satellite. Right? What is the new tangential speed of the satellite? Let's look at the answer now. The equation is 2 pi r over capital T. The new r now plugs in as 4r. I'm going to bring out the 4 out in front, leaving me with 2 pi r over t, which was just my velocity b, which is my original velocity for the tangential speed. So it is going to be 4 times the original tangential speed. Therefore, I can conclude that the new tangential speed of the satellite will increase by a factor of 4 due to being 4 times away than before. Note, it actually has to speed up because now it's further away from the circle. Therefore, the speed has to increase for it to complete around the circle in the same amount of time. That's why this is 4 times as much as before. And this is referred to the tangential speed. There you go.